Radhe Radhe students. In first lecture of Newton's law of motion, we have studied about Newton's first law, second law, third law, and definition of force and types of forces like contact force and non-contact force. In this lecture, we will start with conservation of linear momentum. What is linear momentum? Linear momentum is product of mass and velocity, right? So if any object having mass m is moving with velocity v, then linear momentum of that object will be equal to m into v. So let's start learning conservation of linear momentum. It states that if no unbalanced external forces are acting on a system, then total linear momentum of that system will be conserved, right? So here we will understand and with the help of this example. Suppose two objects are moving with velocity u1 and u2. m1 is moving with velocity u1 and m2 is moving with velocity u2. Since velocity of m1 is greater than velocity of m2, so these two objects definitely collide after some time. So at the time of collision, m1 will exert force on m2 and m2 will exert force on m1, and these two forces will be action reaction pair, so they must be equal in magnitude and opposite in direction. So let's say after collision, m1 started moving with velocity v1 and m2 started moving with velocity v2. So we can say that during collision, force exerted on 1 due to 2 will be equal to negative of force exerted on 2 due to 1. So if we use Newton's second law of force, which is equal to F equal to change in momentum upon time interval in which that momentum has changed. So change in momentum for m1 is m1 into change in velocity of m1. So final velocity of m1 is v1 and initial velocity of m1 is u1. So we can say that change in momentum is m1 v1 minus m1 u1 and time interval delta t. Similarly, if you try to write force acting on m2, then you have to write m2 into change in velocity of second object, which is equal to v2 minus u2 and time interval in which that velocity has changed. So these two time interval will be same because for same time interval, both objects will exert force on each other. So this time will cancel out, and after simplifying it, you will get this result m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Now we will solve some numerical based on these concepts in LM. So first type is problem based on conservation of linear momentum. So here I have taken an example of bullet gun system where I will use 1 for bullet and 2 for gun. We already learned this formula m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So as we know that this gun and bullet are initially at rest before firing. So ub and ug are going to be 0. So if you can put here 0. So if you solve this equation, you will get Vg equal to, this will become negative minus Vb Ub upon Mg. So out of these four quantities, 3 will be given in your numerical and you have to find out fourth one. So you can solve this kind of numerical very easily. So let's move to our next type, type 2. In type 2, we will learn how to find tension in the string. Suppose these three blocks are connected with strings and we have to find tension here and here. This tension force will act between 1 and 2 kg object, and we have to also calculate tension on this rope which is acting between 2 and 3 kg block. So this tension force will act in leftward direction for 3 kg object and in rightward direction for 2 kg object. Similarly, this tension force will act in leftward direction for 2 kg object and in rightward direction for 1 kg object. So to solve such kind of numerical, you have to take whole this system whole as a system, and 12 Newton will act as external force for this system. So according to Newton's second law, F equal to ma. So F external is 12 Newton, which is equal to mass into acceleration. What is mass? 3 plus 2 plus 1. Total mass is 6 kg. So 6 into A. So from here, we can find this value A as 2 meter per second square. To find tension force acting between 1 and 2 kg block, we have to draw free body diagram of this 1 kg block. So only force acting on this 1 kg block is T1. So this force is responsible for acceleration of 1 kg object. So let's write Newton's second law for this 1 kg object. Force equal to mass into acceleration. Mass of this object is 1 and its acceleration is same as common acceleration of the system, which is 2 meter per second square. So tension force is going to be 1, which is mass, and acceleration of system 2. So this tension force T1 equal to 2 Newton. To find tension force acting between 2 and 3 kg, we will draw free body diagram for 2 kg object. 2 kg. So rightward force acting on this 2 kg block is T2 and leftward force is T1. So total force acting on this block is T2 minus T1. And according to Newton's second law, total force acting on any block is equal to mass into its acceleration. Its mass is 2 and acceleration of 2 kg block is same as acceleration of this system, which is 2 meter per second square. 2. We have already calculated this value T1, 2 Newton. So T2 minus 2 equal to 4. So T2 equal to 4 plus 2, 6. So T2 is 6. You can also find this value T2 by drawing free body diagram of 3 kg object, right? So you can solve this numerical way by. So now we will try to solve our third type of problem, which is based on pulley block system. Okay, so here one pulley is attached with some ceiling and 2 blocks are hanged with the help of a rope. Mass of this block is 2 kg and this block is 1 kg. So to find acceleration and tension in this rope, we have to take some variable. Let's say this block is moving downward with acceleration A and this is moving upward with same acceleration A. And since they are connected through a single rope, so tension on both sides will be same. So if you try to draw free body diagram of 2 kg block and indicate all the forces acting on this block, then you have to indicate a downward force which is equal to 20. 20 means mg, mass of this block is 2 and I have taken value of g as 10. So 20. And upward force acting on this block is T. Is there any other force acting on this block? No, only 2 forces are acting. So since this block is moving in downward direction, so 20 Newton force is greater than T. So I will write here Newton law, total force 20 minus T equal to mass of this object 2 into its acceleration. This is equation 1. And if you try to write Newton's second law for this object, you will have to draw free body diagram of 1 kg block. 10 Newton force will act in downward direction and T in upward direction. Since this block is moving in upward direction, so T is greater than 10. So T is upward direction minus 10 acting in downward direction. Total force equal to mass of this block 1 and acceleration A. This is our second equation. As you can see here, there are only 2 variables and we have also 2 equations. Variables are T and A. Here also T and A. So we have 2 variables and 2 equations. So we can easily solve these 2 equations and get value of T and A. Okay. So I hope you understood these numericals. And so that's all in this lecture. I hope you understood all these concepts. Try to solve more numerical based on these concepts from your textbook. Okay. So that's all. Bye. Radhe Radhe to all of you.